the result, the nodal analysis for our original case, natural flow, okay, natural flow of oil well, we get oil rate of 12,146 stock tank barrel per day. Okay, so this is the case where the water cut is 0. So for example, we already continuously produce this well and the water cut increases. Okay, the water cut increases. So now we go to the last case. So this is the second case. It's natural flow. It's easy. So let's say the story is like this. Now the water cut increases to 54. Okay, 54%. So we need to change the water cut in IPR section from 0 to 54. Click done. Okay. And let's say after the water cut increases, now the salinity increases as well. Okay, the salinity of the water. Previously, the salinity is only 23,000, but right now it's 180,000 ppm. Okay, and with this high salinity, we fear there will be problem. Yeah, because maybe the salt will deposit and will create scaling maybe inside our tubing. The salt will deposit and it will block the wellbore because the salinity is too high. Right now it's 180. Okay, 180,000 ppm. So to solve that, we will dilute. We will make the liquid diluted. Okay, so we will inject diluent inside our wellbore. But if you inject diluent to make the salinity smaller, lower, to make the fluid more dilute, you inject water. But of course, if you inject water, then your flow rate will be decreased because now it is heavier. The fluid will be heavier, and now the well will work harder to push the flow. That's why, in addition to diluent injection, we will also install gas lift. Okay, so that the flow will continue. Okay, so in one thing we will inject diluent water to smaller down the salinity to avoid the salt precipitation. Okay, but at the same time we will also install gas lift to support the production. So now we click done. And now go to the option summary. Right now we are on the case 3. And now we change the artificial lift to diluent injection. Here, diluent injection.